Hi, welcome to another episode of PSLE Science Made Simple. I'm Mr. Gerard and I'm a PSLE Science Specialist here at the Pique Lab. In this video, I'll be analysing a past year exam question. I've also prepared this question for you to download for free by clicking a link in the description box below. So, let's get started. Question 16. Jane has a toy acrobat which can swing freely on a plastic rod. Essentially, what happens in this toy system is that when the toy acrobat is first released, it will swing freely from A to B and then to C. Now, if we read on, we will notice that this question is focusing on the topic of energy. And when we tackle questions about energy, we always start off first by labeling the energy conversion. What type of energy do you think the toy possessed at A? At A, the toy is at a height above ground, so it possesses gravitational potential energy. Next, as the toy swings from A to B, it is moving, so it should possess kinetic energy. However, since we know energy cannot be created out of nowhere, where did this kinetic energy come from? It must have been converted from gravitational potential energy. Lastly, to finish up our energy conversion, let's take a look at the toy swinging from B to C. From B to C, it swings back up to a height above ground, so kinetic energy is converted back to gravitational potential energy. This question is asking us to choose the correct graph that shows how the amount of gravitational potential energy and kinetic energy changes when the toy swings from point A to point C. Let's focus on one type of energy first and look at gravitational potential energy. Can we recall the two factors that affect gravitational potential energy? We say that gravitational potential energy is affected by mass and height above ground. Now, when the toy swings from A to C, do you think its mass changes? No, if it did, then Mr. Gerard would also like to play on swings like this to become lighter. So we are not going to focus on the factor of mass here. Instead, when this toy swings from A to C, do you think its height above ground changes along the way? Yes. Therefore, we will focus on the factor of height above ground. When the toy swings from A to B, it is moving from a greater height above ground to a lower height above ground. So does the GPE increase or decrease? It is swinging to a lower height above ground, so the GPE should decrease. However, when it swings from B to C, it is now moving to a greater height above ground, so the GPE should increase. With this analysis, can we try to find our correct answer? Focusing on GPE, we should be looking at the solid lines in each graph. Specifically, we are looking for GPE to decrease to B and increase to C. Which graph shows us a decrease in GPE followed by an increase in GPE? That will be option number 2. I will now put a cross on the parts of the other graphs that are incorrect. With the analysis of GPE, we have gotten the correct answer. But just to be sure, let's use kinetic energy to check our answer. Let us quickly recall, what are the two factors that affect kinetic energy? Kinetic energy is affected by mass and speed. Now, earlier on, we mentioned that the mass of the toy does not change throughout the activity. Thus, we are not interested in the factor of mass. Hence, we will focus on the factor of speed. When the toy moves from A to B, GPE is being converted to kinetic energy. So, kinetic energy should increase. Now, if you struggle to understand this, let me give you a quick analogy. Imagine that you are riding a roller coaster and the roller coaster moves down the ramp. Typically, when you go down the ramp, will you be going slower or faster than before? Faster. So for you to go faster, does the roller coaster need to possess more or less kinetic energy? In order to go faster, the roller coaster has to possess more kinetic energy. Thus, we say that kinetic energy increases from A to B. What about from B to C? Kinetic energy should decrease. This is similar to when the roller coaster goes up the ramp. It typically moves slower up the ramp because it possesses less kinetic energy. Thus, kinetic energy decreases from B to C. With kinetic energy represented by the dotted lines, do we see the graph in option 2 increasing to B and decreasing to C? Yes, this confirms that option 2 is the correct answer. I will conclude this question by sharing a tip. Do you know why I started with the GPE graph first? This is because the GPE graph always follows the object's height above ground. For example, from A to B, the height above ground of the object decreases, so the GPE graph also decreases. From B to C, the height above ground of the toy increases, so the graph from B to C also increases. Next time, do remember to analyze the GPE graph first when you see similar questions that involve a ball swinging, rolling, or moving to different heights above ground. Thank you for watching, and I hope you have enjoyed this video. Found this video useful? Give us a thumbs up and check out more by clicking the links here. You can also subscribe to our channel for more interesting videos. Until next time, stay curious inside and limitless outside. Bye!